ACT and SAT math prep, sample questions and strategies. This is for Youngstown State University's Math Fest 2021. I'm Tom Reardon, Fitch High School for 35 years and at Youngstown State for 38 years. The past 12 years I've been a senior math advisor for Texas Instruments. Press pause as needed anytime during the video. I guarantee that you will learn some new test-taking strategies that you have not ever used before. Guarantee. I always like to start with a quote. This one: as long as teachers give tests, there will always be prayer in schools. So how we prepared to do this, I got a whole bunch of old ACT and SAT tests. Well, I shouldn't say old, but fairly current. And put them into piles by category and subject matter. Now on the ACT, you're allowed to use a graphing calculator on every problem. And there are 60 questions in 60 minutes, so that would mean one question per minute, right? Wrong. Questions start easier and get more difficult. So we suggest on the first 20 you plan on about 30 seconds per question, the middle 20 about 60 seconds per question, and on the last third about 90 seconds per question. That's not a hard and fast rule, but a good idea. We call this the 30, 60, 90 approach. You might have heard that somewhere about triangles. SAT can use a graphing calculator on about 2/3 of the test. The creators of the ACT and SAT test the topics that we teachers teach, but they ask questions very differently from what we ask and how textbooks ask. So here's the plan. We want you to do the problems before you're given the solutions. So we will ask you to pause the video while you solve the problem and then resume when you're ready to see our solutions. Okay, you ready? Here we go. Here's number 1. We'd like you to solve this in as many ways as possible so you can have more than like 90 seconds to do this one. Press pause as needed, resume when you're ready. So again, we ask you to do this as many ways as possible. So here's our first way. We're going to use a system of equations. And so since A and B add up to 90, we'll write A plus B equals 90, A and C add up to 180, and B and D add up to 180. So we have a system of 3 equations with 4 variables. I chose to add the second and third equations together and got A plus B plus C plus D adding up to 360. And then since A plus B added up to 90, I replaced A plus B with the number 90 right here. And then I could subtract 90 from both sides and get C plus D adding up to 270, answer J. Notice that you don't have to know what C and D are individually. And that's one way. I have a couple more. Press pause as needed here, again, anytime. Second way is substituting numbers. This is another strategy that I would like you to consider here. So I'll start off with those same 3 equations that we had before. The first one says that A and B have to add up to 90. So I'm going to let A be 20, and then B would have to be equal to 70. And then once I do that, I can go ahead and substitute A is 20 and C has to be 160. I hope you'll agree with that. And if B is 70, then D would have to be 110 for these two to add up to 180. And since we want to find the sum of C plus D, when we add C plus D, we get 270. So a whole different way of doing this, still got the same answer of 270. Press pause as needed. A third way is to draw it. And I never would have thought of this if someone hadn't shown it to me. See what you think. Since A and B add up to 90, they form a right angle. They're complementary. A and C will form a straight angle. They're supplementary. B and D also form a straight angle. They are supplementary. And so the sum of the measures of C and D are 3/4 of a circle, and 3/4 of a circle would be 270. Pretty clever, huh? Press pause as needed anytime. And that's not the only way. One person came up and said, I did this logically. And I said, what do you mean by logically? And she said, well, A and B have to be complementary. They add up to 90. Okay. A and B have to be each acute angles if they're complementary. And I agree with that. They're both acute. A and C add up to 180, so they're supplementary. And so if A's acute, C's got to be obtuse. B and D are supplementary. And if B's acute, D's got to be obtuse. So here we're going to add 2 obtuse angles. The only answer you could get if you had 2 obtuse angles is to get 270. Wow. And then I have a 5th way. So press pause as needed. This one uses what I call algebra 1. So if I let angle A be represented by x degrees, how could I represent the measure of B in terms of x? Well, since they add up to 90, angle B would be 90 minus whatever x is. And then angle C would, since A and C add up to 180, angle C would be 180 minus x. Now, B and D add up to 180, so I already know B. What would angle D have to be to add up to 180? And that's going to take a little bit of thought. Press pause if you need to think about it for a second. But angle D would have to be 90 plus x. So when you added these two together, you got just 180. The x's would add up to 0, x terms. So now once we have it, let's go ahead and add C plus D. So that would be 180 minus x plus 90 plus x. The minus x and plus x add up to 0, and we're left with, surprise, surprise, 270. Now, why should we teach so many different ways? One of my favorite quotes, I am convinced that students learn in more ways than I know how to teach. So that's why. All right, so here's number 2. This is not going to be as many ways as the last one, but press pause as needed and resume when you're ready. For the solution to number 2, I know we could just substitute -3 and evaluate it. But since you're allowed to use a graphing calculator, and this is an ACT test because there are 5 answers, not 4 like on SAT, I'm going to go ahead and show you how you could use a calculator to do this problem, even though I would want you to be able to do it by hand. So I'm going to go to y equals, and I'm going to type this an expression in for y1. So that's 2x squared minus 3x plus 4. And I'm putting that into y1, so let me show you what that looks like. So you can see that there. That's what I put into y1, okay? And then what I can do is to evaluate this by going off to the home screen. And under alpha trace is where the y variables live. I'm going to press 1 to bring up y1. And just like I can say f of, or g at -3, I can say y1, left parentheses, at -3, right parentheses, which means evaluate what's the expression in y1, but substitute -3 in for x. And here we get 31. So there's our answer, 31, which is letter. Press pause as needed. Resume when you're ready. Number 3, go ahead and do number 3. Take about 30 to 60 seconds to do this. Press pause as needed. Resume when you're ready. Here again, we're going to use a graphing calculator to do this one, even though I know you could do it by hand. In y1, I'm going to type in the expression for f of x. So I'll type in 3x plus 7. That will be in y1. And y2 will be x squared divided by 2. So I'm going to use my fraction template found by doing alpha and then the xt theta n key. and putting x squared in the numerator and then 2 in the denominator. Let me pull that screenshot off so you can see that I did that correctly. And now I'm going to go off again to the home screen, and I'm going to do alpha trace to bring up y1, left parentheses of alpha trace down to y2, left parentheses, and then 4 with double right parentheses. So instead of f of g of 4, I'm doing y1 of y2 of 4. And surprisingly, we get 31 like we got for the last problem, but it's not the same problem, that's for sure. Press pause as needed. This is number 4. Go ahead and do this problem. If you can do it more than one way, that would be great. Press pause to do so. Resume when you're ready to see the answer. Here is the solution for number 4. We need to evaluate a function at 3 variables, and we can't do that with this calculator, but we can get around it by substituting or storing the value 2 for x, 4 for y, negative 3 for z. So that's what I'm going to do. 2, the store key, then into variable x, enter. 4, store alpha 1 for the letter y, enter. And negative 3, store alpha 2 for the letter z, enter. Now, let me pull that screenshot off to show you that I did store those correctly. And now what I'm going to do is type this expression just as you see it, 4x alpha y minus 3x alpha z, and then squared. And what it's going to do is substitute these values, x, y, and z, into this expression, do all the calculations. So I'll press enter, and the answer is negative 22. Press pause as needed. Resume when you're ready. Here in number 5, we're talking about sometimes we need to practice alternative ways to solve problems to assist with our time on the exam so we can make up lost time. So I'd like you to use a calculator to solve this, and check it as well, okay, with your calculator. So please go ahead and press pause to do so. Resume when you're ready to see the answer. So the solution to number 5, we're going to use an app called the Polysimultaneous 2 app. So that's apps Polysimultaneous 2. I'll run that app. And we're going to use number 2, the simultaneous equation solver in that app. And so it says how many equations, how many unknowns? Well, 2 equations, 2 unknowns. Notice it'll go all the way up to a 10 by 10. Oh my. So I want to go on to the next screen. So these 5 hotkeys along the top correspond to these menus here. So to go to next, I'll press graph. And this is where I will type in the equation as you see it. So I'll type in a 5 for the coefficient of x and press enter. A minus sign on top instead of a plus sign. 3 for the coefficient of y, and 29 for the constant. Enter. And then 6, enter. Plus sign is already there, so I'll press enter again. 11 for the coefficient of y, enter. And then negative 2, and then enter. Make sure you do press enter. So here is my equation that I want to solve, or system of equations, I should say, that I want to solve. And so I'm going to go out to solve it. I have to press the graph key to solve it. And you can see that I got really nasty looking solutions, but that's okay. They can be that. let's go ahead and check to show that those actually do work in these equations. So I need to go back to the main. I'll press Y equals to go back to the main, and then number 6 to quit the app. So I'm going to store this fraction in for x. So alpha xt theta n gives me my fraction template. 313 in the numerator, 73 in the denominator. Press the right arrow to get out of the denominator and press the store button. And I'm going to store that in for x. Press pause if I'm going too quickly. Negative sign, fraction template again. 184 in the numerator, 73 in the denominator. Again, press the right arrow to get out of the denominator. Store alpha 1 for alpha y. Enter. Let me show you what that looks like. Make sure I have those right numbers in there for x and y. And now to show that it checks, I'm going to type in the left-hand side of each equation and see if it works. So I'm going to type in 5x minus 3 alpha y. And so what the calculator is going to do is take the current values of x and y, substitute in, multiply, and subtract. And if it's to check in the first equation, it better come up with an answer of 29, which it does. But these numbers have to work in both equations. So let's type in the left-hand side of the second equation, 6x plus 11 alpha y. Again, if I'm going too quickly, pause. It's going to substitute these same values in for x and y, and if it checks, it better come up with -2, and it does. So now we know that not only these nasty numbers are solutions, that they actually do check. Press pause as needed. Number 6, I'd like to go ahead and answer this question. If you could do it more than one way, please do so. Take your time. Press pause as needed. Resume when you're ready. So for the solution, some of you might have done it this way. That is, start off with the equation and subtract 3 from both sides. Divide each side by 6. And then simplify the fraction. Now we need to substitute into 2x plus 1. So when we double 9 halves, fortunately we get 9 and then add 1 to get 10. Perfectly valid way to do this. Another way to do this would be to start with that same equation and divide each term by 3, and we're done. This is using something called algebraic structure. Discuss the advantages of doing this the other way. Think about this. Well, the advantage, it's much quicker, much less chance of making a mistake, and I'll even venture that it's kind of cool. All right, so let's go ahead and try number 7. Again, these can take a little while, so go ahead and take your time. Press pause. Try to do it more than one way if you can. Resume when you're ready. So this is what I call the traditional solution. You'll start off with the 2 equations given, and think of that as a system of equations. And there's several ways you could solve it. I'm just going to add those 2 equations together, divide both sides by 2, and get x equals 17 halves, which I'm not thrilled that it's a fraction, but it's life. I'll substitute into one of the equations to find out what y is. I'll think of 11 as 22 halves, so that when I subtract 17 halves, I get 5 halves. But I'm still not finished because I have to square both of those numbers and subtract them. So when I square them, I get these numbers. They have a nice common denominator, 264 over 4, and that simplifies to 66. Perfectly valid way to do this. Press pause as needed. But let's use something called structure, a different approach. So instead of solving the system, I took the expression x squared minus y squared and rewrote it in an equivalent form by factoring it using difference of two squares. And the reason I did that is x minus y is 6. I can substitute and replace x minus y with 6. The quantity of x plus y is 11. And when I multiply them together, I get, surprise, surprise, the same answer. Which way would you prefer to do it? Notice on the SAT, if you did this problem the long way, you're going to use up a lot of time. You may get the right answer, but you're using up a very valuable commodity of time. Press pause as needed. Number 8. Again, try this a couple different ways. Take your time, press pause as needed, resume when you're ready. Traditional solution. So I'm going to start off with that first equation. We're dividing, they have the same base, so you keep the base the same and you subtract the exponents. Here we have the bases equal, so if they're equal and the expressions are equal, then the exponents must be equal. And I'm going to take the other equation and we have a linear quadratic system to solve. So I can take the second equation and I can solve for y or for x. I'm going to choose to solve for y. And then I'll replace y in the other equation with the quantity of 4 minus x, which means I need to square it, subtract x squared, and get 9. Press pause as needed anytime. I'm going to have to square this binomial. Fortunately, the x squared terms add up to 0. And when I go ahead and solve this, I get x is equal to 7/8. Still not finished. I need to find y and then subtract x. So I'll substitute back into the easier equation, and I get a common denominator so that I can subtract those and get y is 25/8. And now when I subtract y minus x, 25 minus 7 is 18/8. Simplifies to 9/4. Perfectly valid. Using structure, start off the same way. I get y squared minus x squared equals 9, but instead of doing a linear quadratic system, I chose to factor this expression, again using the difference of two squares. And x plus y equals 4 is the same as y plus x equals 4. The commutative property of addition says that. So I can substitute and replace y plus x with 4, leave y minus x alone and 9 alone. And some of you might be tempted to distribute that 4, but I think it would be much better if we divided each side by 4 and got the quantity of y minus x equals 9/4, which was what we were asked to find. Same answer, very different route. Press pause as needed. The last one, again, we'd like you to try this a couple different ways if you can. Press pause as needed, resume when you're ready. So the traditional solution, I have no idea. I tried and I just couldn't come up with one. So I tried using structure. And I looked at this and the left-hand side looks familiar to me. I can factor that. That's actually the square of a binomial. This is called a perfect square trinomial. And it's the square of some binomial, this one. And then what I can do is take the square root of each side. Just remember that when I take the square root, there's 2 of them for 9. Or I can write it as an absolute value equation. I prefer the left, but you could do it through using the right. The square root of this was just going to be a minus b equals plus or minus 3. And we're supposed to find a minus b, but there's another bit of information given that we have to use, and that is the fact that a is smaller than b. So when I subtract a minus b, it's going to be a negative answer. And so the answer is a minus b is equal to negative 3. Not one or the other, just this one. Press pause as needed. We hope that you learned at least one new strategy and maybe some good mathematics. By the way, did my guarantee hold up, I hope? Reminder, please share this with your friends and your teachers. This is the website bit.ly/mathfest 2021 TR for Tom Reardon. Those are all lowercase letters. And we hope you had a good one.